All right, so here we go. The equilateral triangle, you need to, well, before we bisect it, we're going to do that in a minute. We know that on an equilateral triangle, all three sides are congruent. We know that much. And we know all of the angles are congruent as well, and they all measure 60 degrees. And that one I'm going to write really light. We're going to take this triangle, and like with the square, we are going to bisect it. We're going to cut a line from the vertex down to the opposite side. We do so, we get a right triangle. So we don't need that triangle on the right, so I'm going to ghost it out by erasing it. That way I still know where this triangle came from. I know that when I'm dealing with equilateral triangles, I can make a special right out of it, but we just need to look at the right triangle that's formed. Now, we have a 60-degree angle here, we have a 90-degree angle here. The last angle was cut in half, so it's going to be 30 degrees. And now we can come up with all the side lengths. I know that this side length, which is now a hypotenuse, and this side length used to be congruent. I just cut it in half, though. So the ratio of these two sides should be 1 to 2. Would you agree with that? Does that sit well with us?
Yeah.
All right. So if I call this length x, this side would be 2x. Twice as big, right? Whatever this is, this will be twice the size. That's all that's telling us. Now, if I use the Pythagorean theorem, we could then solve and derive this third side. I will save you that experience, not because it's worthless, but because it's not as valuable to you right now. This third side is going to be x times the square root of 3. Now, it's really crucial here. You know which sides go across from which angles. That way you got your ratios in the right spot. The smallest side up here obviously would be this length. It's the smallest, right? All the others are being multiplied by a number bigger than 1. So notice this smallest side is across from the smallest angle, isn't it? So across from the 30 is where the x goes. That's where this table comes in. Across from the 30-degree angle, I'm going to label that side x. Across from the 60-degree angle, I'm going to label that side x root 3. Across from the biggest angle, 90, I'm going to label 2x. Okay. So as before, I'll say it again. This tells us the relationship these three sides have with each other. This does not say that I'm always going to have a whole number, and a whole number times some square root of 3. That is not what it tells me. It just tells me how they're related. It tells me that this side is always twice as big as this side, and this side is always the square root of 3 times bigger than this side. That's the relationship. So let's try another example problem. I'm going to let this side be equal to 9. So in my table, once I've drawn it, I'm going to say x root 3 equals 9. So now we need to figure out what x is, and then double it to figure out what 2x is. Get all of our side lengths. So here's our equation. X root 3 equals 9. Which of the two methods from above would you like us to use? The one where we divide by the square root of 3, or the one where we're going to multiply both sides by the square root of 3? How did I know? It's faster, right? Seems more sensible because it's easier to follow. Okay, so multiply both sides by the square root of 3. Let's see here. Table 5. That's Emilio, your table. What am I going to get on the left-hand side? 3x. Thank you. Okay, and then of course 9 root 3 stays that way. Last step. Let's see, Mario, your table. What do we have to do to get x by itself? Yep. Okay. And remember, whole numbers only divide whole numbers. So 9 divided by 3 becomes 3. And then you have that root 3 that's still there. Okay. So that is the length of x. It's 3 root 3. So I'm going to circle this and say, hey, put that up here. So you should always be making this table and then filling it in. I will expect that when you do your work, folks. After a while, you won't need it, but for now, it's like training wheels. It's going to help you keep in practice that you've got everything you needed. All right, we're not done yet, though. This is what x equals. What do I need to do to this so I get the last number? What do I have to do to both sides? Yeah, just double both sides, right? So times 2 on both sides. If I do so, I get 2x is equal to 6 square root of 3. Remember, whole numbers multiply whole numbers. So there's your other number. We're going to put it up here. Okay. Not too complicated, I don't think. But this is really powerful. This gives us another tool to solve for missing sides of right triangles. with less information, or different information at least. All right, if you would please, let's do some example problems. Turn the page when you're ready. Are you ready? Are you ready? Okay, I'm ready too. A little bit gruffer than I expected. Examples 1 and 2, pretty straightforward. I'll let you do those on your own. I'm going to do example 3 with you though. Okay, so let's go ahead and try out example 3. So it says find the perimeter and area of each figure and then give your answers in simplest radical form. So again, you're leaving your answers exact form. Okay, the first shape is a square. What do you think I'm going to do first? Draw a square, something really closely approximating it in my view. Okay. And it tells us the diagonal of this square is 20 centimeters. Okay, what kind of right triangle do we have here? Name it, please. What kind of right triangle do we have? Based on what we just learned. Based on what we just learned. Which special right triangle is it? Is it a 45, 45, 90 or a 30, 60, 90? Oh, okay. So you just cut a 90-degree angle in half. You got 30 degrees out of it? Come on, gang. You just did this very same thing right here. Right here. I even recorded it, so it's on the history books. Oh, goodness. So this is a 45, 45, 90. Okay, stop going through the motions, folks. All right, so now, in order to find the perimeter and area, I need to know the side lengths here. So in order to find the side lengths, I'm going to draw my table. So this is a 45, 45, 90. Okay. And what are my ratios? Yes, ma'am. Yeah, close in terms of give me using the variables though. What are each of the ratios that go here by variable? X. Next one's x, and last one x square root of 20. Nope, x square root of 2. Okay, those are the ratios for every single 45, 45, 90 you ever do. Those will be your ratios. So the 20 is across from which angles? Is it across from the 45s or across from the 90? So it's across from the 90, so I'm going to put 20 equal to x squared root of 2. We can now solve that equation, and then we will know the lengths of those other sides. So x squared root of 2 equals 20, multiply by both sides by the square root of 2, and you get 2x equals 20 square root of 2. Therefore, x must equal 10 square root of 2. All right, so we'll put that here. So we now found out our answer is, or at least the side lengths are 10 square root of 2. So in order to find the perimeter, what do we have to do with that number? It's a square, so what should we do? We're trying to find perimeter. How do we find perimeter of a square? Yeah, add up all four sides, which is the same as multiplying by what? By all four sides are equal, so if you multiply by 4, it's going to give you 10 root 2 plus 10 root 2 plus 10 root 2 plus 10 root 2. So the perimeter is 4 times 10 root 2. So whole numbers multiply whole numbers, so we get 40 square root of 2. There's your perimeter. You okay? Sit well? Okay. And the area, okay, here's our area. It should be base times height, which will be 10 square root of 2 times 10 square root of 2. The nice thing about it, that's all multiplication. So multiply the whole numbers, what do you get? How much? 100. Multiply the square roots, what do we get? Simplify it. Square root of 2 times the square root of 2 is? Very good. So this becomes 200 units squared. So there's your area. All right. Am I moving too quick? Okay. I see some people that are fighting to stay awake. That's worrisome to me. Didn't realize I was ever going to be so boring in my life. Who knew? Who knew? You guys think math is incredibly boring, I'm guessing. So very dry, so very formulaic. Guess what? You're doing math wrong. Which means I'm probably doing math wrong with you. Math is not boring. Okay, I used to work on skyscrapers. Okay, and I get the same sort of exhilaration when I make a breakthrough mathematically as I do building up on those buildings that are way up in the sky. The reason being is because I feel like I'm reaching the edge of the known universe for me, and I just looked a little bit farther into it. So it's exciting. I get a chance to have a control over my life and over the world in a way that I never had before. So for me, this stuff can be really exciting. Of course, doing a problem like this can also be really boring, so I can appreciate that too. Move with me though. And once you see how to use this stuff, maybe you'll get the same type of excitement. Maybe that sense of wonder will come back into how you do your work and how you're educated. So, last one, equilateral triangle. It says it has a height of 24 inches. Okay. Well, I know that this is 60 degrees, and this angle is going to be 30. So this is a 30, 60, 90 triangle that we're going to use here. Which means I know all the ratios I'm going to be using. 30, 60, 90. Okay. What are my ratios, folks? First one's x, second one? X squared to 3, and? Excellent. So keep having to say that over and over. It's going to get locked into your memory. You're going to be fine. All right, the 24. Which angle is it across from? It is across from the 60. Very good. So that means I'm going to put the 24 right here. And now I get to solve for x. And once I solve for x, I get all the other numbers pretty quickly. So we get x squared of 3 equals 24. So moving quickly, we are going to get 3x equals 24 square root of 3. Can you see what I just did there? Can you see that we just multiplied both sides with the square root of 3? Okay. And then the last step will be dividing by 3, so we end up with x equals 8 square root of 3. Okay. So now I'm moving really quickly. But not too quickly, right? Okay. Again, we had to find the perimeter and area. Let's see. Well, we need the other side lengths. So we got 8 root 3. That's great. And what's the hypotenuse going to be?
60.
Very good. Just double the 8, right? Yep. Excellent work. Okay. So perimeter. We want perimeter of the entire shape, though. It's not just the right triangle, but the entire shape. Okay. So perimeter is easy. That's going to be 16 root 3 plus 16 root 3 plus 16 root 3. So I can just write that as 3 times 16 root 3, because it's 3 16 root 3s that we're adding together, right? So what do you get? 3 times 16, what do you get? 30 plus 18 is 48, is that right? So your perimeter is 48 root 3, is that right? Am I on point?
Yeah.
So you want to write that as a decimal, don't you dare, because it says right here, leave your answers in simplest radical form. So don't you dare. Leave it like that. That's a perfectly good answer for us. And we'll put units, of course. Last thing, area. Area, you need a base and a height. Well, we got both of those. The base is going to be the same as that hypotenuse, of course. So we're going to use the base as 16 times the square root of 3. What's the height, guys? 24. And it says we have to multiply that by 1/2 in the front. So 1/2 base times height to find the area of a triangle. Okay. So whole numbers, we're going to multiply those first. You're going to get 16 times 24, and you're going to divide by 2. So I'm going to write that all out. So this says 16 times 24, square root of 3, and then divide all that by 2. Whatever that simplifies to, that's our answer. 12 times 16 is 160 plus 32. I get 192 root 3. Can anybody confirm? I get 192 root 3. Am I right? Anyone confirm that? Okay, as long as someone's got our back there mathematically, make sure we're doing our work right. Okay. All right. Would you please do examples 1 and 2? I think you should be able to manage examples 1 and 2. Yes, hurry, because time's running short. So set up examples 1 and 2. Solve for the things they want you to solve for. Those problems should be much easier than ones we've already done. You're going to be like, this feels way too easy. It's okay. It should feel that way. So work those problems, please. Because I have 3 more I want you to do. So work quick.
And I think I've noticed that for another one. Okay. Is this the same thing?
Okay.
And you said you did too?
Yep. Yes, I'd love to. I like this clipboard thing you're doing. Oh, okay. So you were using your modeling language. This 3's cross function. So this 3 should have gone right here, because you did more work than you needed to. Your problem is easier than mine. Oh, solid. Excellent. Just powerhouse.
So you just plug it in, and it's 3 square 3. So then you multiply 2 times 3.
So this part goes there, and I'll just go far away, but leave it there. There you go. That's it. That's it. This is going to be more like this part. I see that. Double 3 would be good. So there's number 3 necessary on this particular problem.
16 square root 6.
So it's just 6 for this particular problem. Turn the page. Some older problems. Hey.
Don't forget about the multiplying. This is the equals that, so that's a good thing. So you can
You're ready to turn the page. Okay, sorry, one.
That's what I got.
Did you get it?
Yeah.
Okay. Okay.
Did you check the last one?
I don't know. Did I check the last one?
You just checked the first one.
Good. Okay, last page. ones, actually. That one's right. This one looks like it's being used. You're doing fine. This is right. This is good. So the square root of 2 times the square root of 2 is whole number 2. So this is going to become 2 times x. That's your next line. Try it. So 2x equals 62. And what do you want to do next? Done. Oh, I like that. One big bar there. Done. That's it. You killed it. I don't know what this means because that's kind of weird. This one is here. Because you're solving for x, right? So it's a simple typo. It's not a big deal. Oh, this is x. Therefore, this must be by the hypotenuse part. Oh, that's wrong. Oh, that's not right. That's good. So the bar. The 12 is across from the 64. So that's. Yep, that's good. Okay. Oh, I see. So we can straight. So that will. So this is this one. You're right. Yes, you're doing it. Keep moving forward. All right. Gang, I love working with you, but go get something to eat. You have 2 homework assignments then. So you have the 8-2, which we didn't do last time. And of course, you just learned 8-3. So you're ready to go, and it's not due until next Tuesday. Ugh, next Tuesday. Have a great day. I will see you all. Friday. Oh, I'll see you all tomorrow as well. Yes, that's true.